Okay, in this video I'm going to take a look at another commonly looked at map or group of maps, the exhaust gas recirculation maps. This is the point at which I ended the last video, so I'm just going to click, I'm just left clicking through here. Now this and these are both related to exhaust gas recirculation, but I'll come back to those because they're not typical obvious exhaust gas recirculation maps. Okay, now these are more like the ones we would expect to see. We've got sort of shape where it's flat, up and down, up and down, up and down, up and down, and then almost flat at the edge again, and similar sort of pattern here, similar sort of pattern here, and so on. And there's a number of these. There's another one there. I think that might be the last of them there. Yep. Now these are here in numbers, as in more than one, for a variety of reasons. One, the engine uses multiple injections, so you've got different types of injection or different scenarios of injection, so there's different types of exhaust gas recirculation. On top of that, you've also got the fact that the car will be equipped with a catalytic converter, so there will be regeneration to consider. So some of these maps may well be to do with regeneration. Right, now what I'll do is I'll just pick one of these. I'll pick one that looks most like, let's say, a traditional map. That one there does, and that one there does. Again, I've already been through these once just to make sure that I know what I'm doing when I come back to them, because the EDC17 file is quite complicated. Winols usually finds these, if not all of them, then certainly one or two of them. So you will find these via Winols map search, so they're not difficult ones to find. Right, now let's take that one then. So there we are, we've got the exhaust gas recirculation map. Now if we look over here, we've got engine speed, revs per minute. Again, if I go up to the original values, you can see it originally ran from 1200 to 7000. The fact that it went well above 6,000 is a clue to the fact that it's probably revs per minute. So again, I've used the factor 0.5 there. So I've got engine speed, revs per minute, 0.5. If I go to look at the other axis, just like in EDC16, it's milligrams per cycle or milligrams per stroke, and I'm using the factor 0.01 here, just like I would in an EDC16. So very, very similar to an EDC16. Here we have the output to the map. Now realistically, what we're looking at here is a 2-litre engine. So a 2-litre engine with 4 cylinders, the cylinder is probably about 500 cc's, 500 cubic centimetres, which means it can hold about, let's say, in the region of 500 milligrams of air, let's say. Now, if it can hold about 500 milligrams of air, and we double the air pressure by using double the boost, that will give us about 1,000 milligrams of air. If we assume that the boost is going to be in the region of 2.5 times, a little bit less maybe, a little bit more maybe, but somewhere in the region of 2.5 times, then perhaps we could expect to get a boost of an air figure of somewhere in the region of, let's say, certainly over 1,000, but maybe 1,200, maybe up to 1,500, but certainly in that region. So when we look and we see a value here of something like 1,200, and if I go again over and look at the original value, it was originally reading 12,000, which is obviously ridiculous. So we would be expecting a value of somewhere in the region of 1,200, 1,400, 1,500, but that area for the maximum value. And that's the sort of value we've got as long as we use a factor of 0.1. In other words, we've knocked a decimal point off. So what I've done is I've called this one the EGR map. I've said that the description of what's going on is it's actually the mass airflow or MAF values, and I've put in here for the unit milligrams per cycle of air, just to remind myself that what I'm talking about is air. Now, because this is being measured by the mass airflow meter, this is the value of air that is coming into the engine as measured by that meter. So when this value drops, it means that there is apparently less air coming into the engine, which is obviously impossible. So whenever this drops, then there must be air being supplied from somewhere else, and of course there is. It's the exhaust gas being fed back into the engine. So the difference between these values and the maximum is the amount of exhaust gas going back into the engine. So if we've got a picture here of 800, so there's a figure there on that picture of 800, and here the maximum we've got is 1200, then what we're saying is we could have 1200 of fresh air. What we've actually got is 800 of fresh air, so therefore 1200 minus 800, we must be putting in 400 of exhaust gas. So a third of the mixture that's going into that cylinder is made up of exhaust gas. It's getting 2/3 fresh air and 1/3 exhaust gas. So that's what this is showing us, and it's virtually identical to what we would have seen if we were looking at an EDC16. The only difference being that the engine revs is using a factor of 0.5 instead of a factor of 1. And the other difference being that there might well be many different versions of this. They'll all use the same factors, so they'll all be the same in that sense. So if I look at this one, the figures, you can see that they are virtually the same. In fact, it could well be the same map. So that one is virtually identical, so that one and that one might well be the same map. That one there looks as if it might well be the same map as that one. So if we look at that one, let's put that over there, and then we pull that one up, just move that one there. At a quick glance, I would say that they are probably the same map as well. So in fact, what we've probably got here then is we've got that map and that one, and then it's repeated there and there. So those two are effectively the same. So what we've got are two conditions that are then repeated. We've got something that's completely different over here. So this one is actually slightly different, but again, all the factors would be the same. And then we've got another one here. Looks fairly similar to the first one we looked at, but there's a difference up here at the beginning. You can see there's a difference there. Now another thing that's worth pointing out on here is that if we look at usually nearby, and the obvious one appears to be here, usually nearby there is some kind of peak value map. And this is often a good way of double checking what sort of figures you should be considering as a maximum, because if I just hold that on there, I don't know if it shows up on the video, but it shows up to me looking at it. It tells me that that line there is at 1500. If I go to text and I manage to lose it, where have I gone? That's him. I'll go back again. So if I go to text view, there we are. We can see that they're all what will be with a factor 1500. So this is probably the maximum, in other words the system's maximum. So it's saying that the maximum ever amount of air that a system would consider possible going into a cylinder is, once you've used a factor of 0.1, is 1500 milligrams, and we had a maximum on the map, there we are, of 1200. So in effect what this is saying almost certainly is that that's a design maximum of 1500, and probably the reality maximum is 1200, and then these are the values that the exhaust gas recirculation valve is going to be tested against. Now while I'm here, I'll just mention the fact that because the exhaust gas recirculation valve, its actuation and its performance are going to be tested, that is why we have these maps here, because these are the ones that check the amount of deviation from what should be happening compared to what is happening. And this is a map to each of these are checking to see the amount of deviation to see if the valve is performing as it should. And as soon as the valve does not perform within the parameters laid down in these maps, you will get an error code flagged, because it's a legal requirement in most countries for pollution control that the EGR should function correctly. Now obviously if you choose to try to change the software to delete the EGR function, then that is entirely up to you. And then of course you need to either delete the ability of these maps to function, or delete the error codes, or delete the way in which the EGR is functioning. So delete the functionality of this map in such a way that it's expecting different values. Now you can't simply, especially on EDC17, just change all these values, because if you do, the maps we've just been looking at over here will pick up the fact that those values don't make sense anymore. So you can't simply do what early EDC15s allowed, which is to set this at a maximum value and then everything's okay. On some EDC16s you can get away with setting this to a maximum, but on EDC17s you will not get away with setting this to a maximum. You can set it to a maximum, but other things will be required, because if you don't, you will get errors being flagged. Right, I'll stop there, because in the next video what I want to do is I want to talk about these two maps here, so I'll stop there.